These are the first set of gas law calculation notes. In this video, we're going to cover sections A, B, and C. So as a reminder, our variables of gases, we've been talking about these since the beginning of the unit. We have moles. Moles, a variable, if we see that in a formula, we would see N to represent that. And then the unit on that would be moles. Volume, our variable that we would see in an equation, is uppercase V. Volume, our standard unit for measuring volume when we're dealing with gases, is liters. For pressure, our variable that we see is capital P. Our standard unit for pressure is atmospheres. Our abbreviation for that is ATM. And then temperature, our standard unit, our variable that we would see in an equation is capital T. And our standard unit for temperature is Kelvin. This makes it so that we don't have any negative temperatures because the gas relationships don't work if we're dealing with negative temperature values. And so in order to convert from degrees Celsius, which is our normal temperature we see in science, to Kelvin, we can use that relationship that Kelvin is going to equal degrees Celsius plus 273 with those. So that's something we're going to need to know now that we're doing calculation problems, is we need to make sure any temperature, if it's given to us in degrees Celsius, we need to convert to Kelvin. One other thing we need to do before we can start doing calculations is we haven't talked about a lot of calculations with gases because gases behave differently than solids and liquids. Their volume is dependent on the container that they're in because they change sizes for that container, and that's going to impact pressure, those collisions with the container, and that is also impacted by temperature. And those things don't have an impact on solids and liquids. So we have to set the conditions that something is happening at in order to do calculations with gases. There is such a thing as standard temperature. Standard temperature is 273 Kelvin. And you'll notice that's the same as that 273 that's in our conversion. So if our problem ever mentions standard temperature, that is the temperature we would use. If our problem ever mentions standard pressure is 1 ATM, and that's what we would use. If a problem ever says at STP, so at STP means at standard temperature and pressure, so we would then know that these two values are going to be used for pressure and temperature in our problem. So let's start to look at those relationships that we previously just spoke about. Now we're going to do some calculations with those. Our first one is Boyle's law. And Boyle's law is tells us that pressure and volume have an indirect relationship or inverse relationship. And we talked about how when we have high pressure, that means it's going to be a low volume. And then we talked about how lower pressure will mean a high volume. And so those have an inverse relationship. And we looked at modeling those previously. So the equation then that we can use to do calculations where pressure and volume are changing, and with these, our temperature is going to stay temperature stays constant. So we're not going to see anything about temperature in our problem. The relationship we use is P1V1 equals P2V2. And with this, remember uppercase P is our variable for pressure. So and then uppercase V is our variable for volume. This showing the 1 and the 2. The 1 just means this is our before pressure, and then the 2 just means this is my after pressure and my after volume. So with these problems, we're going to be given 3 of the 4 things from this formula, and then we're going to need to make sure we pair up if there's a pressure and volume that are happening at the same time. Those have to go on the same side of our reaction. So let's look at this, an example. A sample of CO2 gas, see we're working with gases, occupies a volume of 3.5 liters at 1.5 ATM of pressure. what pressure would the gas exert when the volume was decreased to 2 liters? And so for something like this, if we're recognizing what equation we're going to use, I'm given a volume and a pressure. I'm asked to find a pressure, and I'm given another volume. And so when I only see volume and pressure, that means I'm going to use Boyle's law. And for this, I'm going to just use whatever was listed first. That's good. Those are going to be my ones. So volume 1 is going to be 3.5 liters. And then the pressure that corresponds with that, pressure 1, is going to be 1.3 atm. Then what pressure would the gas exert? Well, pressure 2, that's what we're looking for. That's our unknown. When the volume was decreased to 2 liters, so 2.0 liters is given. We can use the units, so those units of liters, Kelvin, atmospheres, knowing those is going to help you identify what you're given as well. And so with our formula, we've got that pressure 1 times volume 1 is going to equal pressure 2 times volume 2. I can plug in what I know. I know that 3.5 liters times 1.3 atm is going to equal pressure 2, which is what I'm looking for, times volume 2, 2.0 liters. And now it's a matter of solving for my unknown. If you want, you can multiply these together first. But what I'm looking at here to get P2 by itself, I need to, whatever the opposite of multiply is, I need to divide by 2 liters on both sides. That's going to cancel those 2 liters there. That also cancels my units for liters here. And then I can go ahead and grab my calculator, and I'm going to do 3.5 times 1.3. And then I'm going to divide by that 2 on the bottom. And I got 2.275, and this is pressure 2. Pressure has a unit of atm, so I need to put that unit of atm on my answer. So pressure 2 is 2.275 atm. Let's try another one of these. If you want, pause, try and get the set up, and then come back to check your answer. Ammonia gas occupies a volume of 4.5 liters at a pressure of 0.95 atm. What will the volume occupy at standard pressure? So again, I'm given 2 volumes, or it's talking about 2 volumes. It's also talking about 2 pressures. So anytime I have 2 values for volume, or 2 values for pressure, and then one value for volume, and it's asking for another one, that's an indicator that we're going to use this Boyle's law relationship. I like to go through and kind of list everything out where it says, okay, the first volume it's giving me, I'm going to just make that volume 1. So that's 0.45 liters. Pressure, that's at the same instant as the volume, so those are going to both be my ones, 0.95 atm. And then if I am now looking at those changes, that means I'm going to have a second volume and I'm going to have a second pressure. If one of these changes, the other one is going to have to change. All right, so it is giving me standard pressure. Well, standard pressure, that's one of those values that we need to go back and look, and standard pressure is 1 atm. And so that's going to be my P2. I'm looking for volume 2, and I have this information now that I can plug that into my equation. So Boyle's law is that pressure 1 times volume 1 equals pressure 2 times volume 2. I'm going to plug in my values. 0.95 atm times 0.45 liters equals 1 atm times volume 2. 1 times volume 2, I'm going to get that 1 away by dividing both sides by 1. The opposite of multiply is divide. So that's going to cancel, meaning that V2 is going to equal 0.95 times 0.45 divided by 1. So I'm going to grab my calculator. And I got 0.4275. When we look at this, we have units of ATM. Those are going to cancel out. And so that's what shows me that that unit of liters is what's left, which corresponds with what I'm looking for, which is a unit for volume. So volume 2 was 0.4275 liters. If you wanted to round, you could say 0.43 liters. With that. One thing we can look at is we know that pressure and volume, they have an inverse relationship. So if my pressure went from 0.95 to 1, well, pressure went up, so we should then expect that our volume should go opposite. Volume should go down. And our initial volume was 0.45 liters. Our final volume was 0.43 liters. So we did see that relationship occurring. All right, the next set of these notes will be in a new video. Reach out if you have any questions.